Okay, for number 1, we're going to divide each side by 3a, and we're going to get x is equal to 5bc divided by 3a. For number 2, we're going to move this 2b across the other side, and remember, it flips signs when you do that. So we have 5bc plus 2b, and then we're going to divide each side by 3. So we're going to get x is equal to 5bc plus 2b all over 3. For number 3, we're solving for x, which is in this term, so we're going to move this term over, and it's going to flip signs. And then we're going to divide by 2a. Be careful, you cannot cancel 2 and 20 because there's no 2 here to cancel. You can't cancel the a's because there's no a here to cancel. So that's a simplified fraction. 20ad minus 5b all over 2a. Here the x is showing up in multiple terms, so we isolate it by factoring it out, and we get 3ab plus 4a equals 2c. And then we're ready to solve by dividing. We divide by 3ab plus 4a, and then that's the answer. X is equal to 2c over 3ab plus 4a. And just be careful, you cannot cancel this and this because there's no 2 here to cancel. If there's a lot of steps going on, you can just follow the roadmap: parentheses, fraction, simplify, isolate, divide. To get rid of the parentheses, we'll distribute this, and we'll get 2 times 3 is 6, and we have abx minus 3 times 5 is 15, and we have ac equals 4ac. We got rid of that. There's no fractions. We can't simplify because there's no like terms. We're going to isolate this term by moving this term. So we move this across the equal sign, and it flips signs when you do that. And then we're ready to divide. We divide each side by 6ab, and we're going to end up with 4ac plus 15ac. Oh, wait a minute. I got to be careful. Those are like terms. These are like terms, and they have to be combined. So this becomes a 19ac over 6ab. But then the a's cancel, so our final answer is 19c over 6b. And yeah, that we have to be careful. These were like terms, so they had to be combined. And then I have that a that can cancel. Okay, in this problem, there's no parentheses, so we can skip that, but there are fractions. And the LCD is just multiplying everything together is 2bcx. And you can put those variables in any order. But if you take that 2bcx and you multiply by 3 over x, plus, and you have the 2bcx, and you multiply it by the next thing, which is 3 over 2b, and you have that 2bcx, and you multiply by that third thing, which is 5 over c. And then you can cancel. These x's cancel, 2b cancels, and the c cancels. So when you multiply it together, here you have 2 times 3 is 6 bc, and then we have 3 times cx is equal to 5 times 2 is 10 bx. So now we got rid of the fractions. We can't simplify because there's no like terms, but now we're ready to isolate. This term and this term have x's, so they need to be on the same side of the equal sign. So I'm going to move this term over, and I'll get 6bc is equal to 10bx plus 3cx. So now I've isolated. Now I'm ready to, I need to continue to isolate by factoring the x. I have 10b plus 3c equals 6bx. And now I'm ready to divide. And I'll divide each side by this here because I'm solving for x. So my final answer is going to be 6bx divided by 10b plus 3c. And be careful now, you can't cancel the 3's because there's no 3 here. You can't cancel a 2 because there's no 2 here. You can't cancel the b's because there's no b here. And so you can't cancel anything, so this is a simplified fraction. Okay, in this problem, to get rid of the fractions, I'm going to multiply each side by x plus 3. When I multiply this side by x plus 3, the x plus 3 cancels. And when I multiply this side, I distribute this through here. And I get 2bx plus 6b. And then I want to isolate this term, so I got to move this term over. And I end up with 4 minus 6b is equal to 2bx. And I'll solve by dividing each side by 2b. But you got to be careful because this is not a simplified fraction. Because 2 is divisible by every one of the terms, you have to divide it out. This becomes a 2, this becomes a 3. And so our final answer is 2 minus 3b all over b. This b can't cancel because there's no b here to cancel. Okay, in this problem, I'm going to write a little roadmap. Parentheses, fractions, simplify, isolate, divide. I'm going to get rid of the parentheses by distributing this. When I multiply this times this, I multiply across the tops and across the bottoms. 4 times 2 is 8. Minus, when I multiply this times this, I multiply across the top and across the bottom. Equals 1. So now I got rid of the parentheses. Now I'm going to get rid of the fractions by multiplying by the LCD, which is, I guess, 40. They can both go into 40. So if I multiply 40 here, and 40 here, I cancel. 8 goes into 40 5 times. I multiply there and get 15x. 20 goes into 40 2 times. I multiply 3 times 2 is 6. 40 times 1 is 40. So I got rid of the fractions. I can't simplify because I have no like terms. Now I'm ready to isolate. So I'm going to move this over. So 15x is equal to 40 plus 6, which is 46. And now I've isolated. I'm ready to divide by 15. And I'll get x is equal to 46 over 15. Okay, in this problem we have students, Punahou students, and those that go on to get an advanced degree. So I'm going to put students and then advanced degree. All right, 3 out of every 10 students, so 10 total students, 3 of them get advanced degrees. That's one fraction. And then the second fraction, and by the way, doesn't matter what you put up on the top and bottom as long as you're consistent, which is why I did it like that. Anyway, if the senior class has 450 students, that's that. How many of them get advanced degrees? So when I cross multiply, 10x is equal to, actually I probably would cancel this and this, but if you're using a calculator, I guess there's no reason to calculate that or to cancel that. So I got 3 times 450 is 1350. So x is equal to 135. So 135 students get advanced degrees. Okay, here a mechanics shop has 35 quarts of oil to change the oil in 7 cars. So I'm going to have quarts over cars. So 35 quarts does 7 cars. In the second scenario, how many quarts? So that goes on top to do 28 cars. And actually, you can cancel these 1 and 4, but let's say you didn't see that. I'm just going to use a calculator. So 7x is equal to 35 times 28, and I get 980. So x is equal to 980 divided by 7, which is 140. So 140 quarts. Okay, this is a work rate problem, and the question is how long would it take them to work together? So x equals time together. Now remember, you're going to put the individual efforts on one side and the combined efforts on the other. So 10 is an individual effort, so that goes over here. 12 is an individual effort, so that goes over here. And x is a combined effort, so that goes over there. Now, The LCD is 60, but let's say you didn't think of that, and you can just multiply them together and make the LCD or the A denominator 120. And that might be easier because when you go to cancel, you just get the other number. So 10 goes into here 12 times, and we get 12. 12 goes into here 10 times, and we get 10. This is, oh shoot, I forgot my x. I need x in there. This is 120x because there's an x down, oops. There's an x down there. So when I cancel this, I get 12x. When I cancel this, I get 10x. When I cancel this, I get 120. So bring this up here. We have 22x equals 120. So x equals 120 over 22. Now I can try and divide this out, but I get a weird repeating decimal. So I get 5.4 something. So this is 5 and something over 22. Now 22 times 5 is 110. If this time this is 110 and I need 120, this up here has to be 10. Because this times this is 110 plus this is 120. But this is not reduced. So the answer, once I reduce it, is 5 and 5 over 11, and this is hours. Okay, working together, they take 30 minutes, so that's combined. If Leslie works alone, it would take her 40 minutes. That's individual. How long would it take Chad to work alone? So x equals Chad's time alone. So I have 1 over 40, oops, let me write that better, plus 1 over x is equal to 1 over 30. This is the combined time. The combined time goes over here. Now again, the LCD is 120. Actually, I'm just going to leave it 120. You can make it 1200 if you want. So 120x. Now, 40 goes into this 3 times, so we have 3x. This x cancels, so we get 120. And 30 goes into 124 times, so we get 4x. So when we bring this over here by subtracting, we get x is equal to 120, or 120 equals x. And this is in minutes, so it's 120 minutes. And if you converted that to 2 hours, that'd be fine. If you square root 16, we get 4. And when you take this out, you divide the exponent by the index. 4 divided by 2 is 2. Now this can come out, but this can't because 5 is not divisible by 2. So I'm going to rewrite this as 25y to the 4 times y. I bring this out and I get 5. I bring this out and I get y squared. And then we're left with the square root of what couldn't come out. Okay, everything can come out except for this y to the 5th because 5 is not divisible by 2. So I'm going to rewrite this as 36 times the square root of 25 x to the 4 y to the 4y z to the 8th. And I can take out the 25, it becomes a 5. This becomes an x squared. This becomes a y squared. And this becomes a z to the 4th. I'm just dividing all of these exponents by the index. Then I take this 5 and multiply by the 36 that's already out there and get 180. And then I have x squared, y squared, z to the 4th. And what couldn't come out was the square root of this y. This problem's easy because 125 is a perfect cube. We take this out and we cube root it and get 5. We take this out and we divide the 6 by the 3 and get a 2. And then we take this out and we divide the 9 by the 3 and we get 3. And there's no radical here because everything came out. 32 is a big number. You might recognize it as 16 times 2, but if you don't, we got 2 times 16. this is 2 times 8, this is 2 times 4, this is 2 times 2. So this is equal to 2 to the 5th power. But we're not going to write it as 2 to the 5th power because 5 is not divisible by 4. So we'll write it as 2 to the 4th times 2. X to the 8 is fine the way it is, but y to the 13th isn't, so we'll write that as y to the 12th times y, and z to the 22 we'll write as z to the 20 times z squared. I'll take this out and get a 2. I'll take this out and get x squared. I'll take this out and get y cubed. I'll take this out and get z to the 5th. And all I'm doing when I take these out is I'm dividing the exponent by the index to get the new exponent. And then I'm going to be left with the 4th root of everything that couldn't come out. The 2, the y, the z squared. Okay, first of all, this negative is okay because this is odd, but it does need to come out. So this is going to pop out, and then 54 will break down as 2 times 27. And I'm going to stop right there because this is equal to 2 cubed. So I'll have the negative that came out times the cube root of 2 times 27, and I'll write x to the 7 as x to the 6 times x, and y to the 14th is y to the 12 times y squared. Then I'll take this out, it becomes a 3. This becomes an x squared. This becomes a y to the 4th. And that's it. So on the outside, we've got the negative 3x squared y to the 4 times the cube root of the things that couldn't come out. The 2, the x, and the y squared. And make sure your radical extends over everything. Okay, 32 is 16 times 2. You can use a factor tree, but I know 16 is a perfect square, so I'll write it like that. And then x to the 3 I'll write as x to the 2 times x, and y to the 10 is fine the way it is. I square root the 16 and we get 4. I take this out and I get x to the 1, and I take this out and we get y to the 5. And then we're multiplying by the square root of the 2 and the x that couldn't come out. The largest perfect square factor of 40 is 4 times 10. So I'm going to rewrite this as 4 times 10. X to the 16 is good the way it is, but y to the 9th has got to be written as y to the 8th times y. I'll square root the 4 and we'll get 2. I'll take this out and I'll divide the exponent by the index and get x to the 8. I'll take this out and we'll get y to the 4. 8 divided by 2 is 4. Times the square root of the stuff that couldn't come out, the 10 and the y. You can use a factor tree to break this down, but if you realize that 125, which is a perfect cube, can go into this, I'm going to stop right there. So this is going to be the cube root of 125 times 2, that's 250. X to the 9 is good the way it is. Y to the 20 is 18 plus 2. And z to the 7 is 6 plus 1. So when we take this out, we cube root it and we get a 5. Take this out, 9 divided by 3 is 3. Take this out, 18 divided by 3 is 6. Take this out, 6 divided by 3 is 2. Let me write that better. And then we have the cube root of the things that couldn't come out, the 2 y squared z. And cover everything with the radical. Well, you might see that this is 16 times 4, but let's say you didn't realize that. So let's break down 64. This is 8 times 8. This is 4 times 2. This is 2 times 2. This is 2 times 2. So this is equal to 2 to the 1, 2, 3, 4, 5, 6. But 6 is not divisible by 4. So I'm going to rewrite this as 2 to the 4th times 2 squared. That's 2 to the 6. 9 is not divisible by 4, so I'll rewrite that as x to the 8th times x. 19 I'll write as, let's see, 16 and 3. And z to the 12 is fine the way it is. This is a 4 out here. Okay, so I'll take this out and I'll get 2 to the 1. I'll take this out and I'll get x to the 2. 8 divided by 4 is 2. I'll take this out and get y to the 4. 16 divided by 4 is 4. And this will be z to the 3. And then it's times the 4th root of everything that couldn't come out. 2 to the 2 I have to simplify as 4. And then we've got x and y cubed. Okay, we have 3 things going on. The first thing I'm going to do is apply the negative, which inverts this. So I have 27 over 1, or just 27, but now it's to the positive 2/3. Then I'm going to apply the bottom, which is cube rooting it. The cube root of 27 is 3. And finally, we just have the numerator in the exponent, so we square it and get 9. This is the square root of all of this. So I square root 36 and get 6. I square root 25 and get 5. The first thing I'm going to do is apply the negative. That inverts this, so that turns into 64 over 27, but now it's to the positive 1/3. And then I cube root this. Cube root of 64 is 4. The cube root of 27 is 3. There are 3 things happening in the exponent here. The first thing I'm going to do is a negative, which just inverts this. So this remains negative, but now it's 125 over 8. And now it's to the positive 2/3. This negative is okay because this is an odd index. So I'm going to apply the bottom, which is the cube root of everything. The cube root of the negative remains negative. Cube root of 125 is 5. And the cube root of 8 is 2. And finally, we have the new exponent left, and we square it. This negative is going to square out and become positive. This is 25, and that's 4. Okay, be careful. Don't multiply these 3's. These are bases, and bases stay the same. So this is going to be 3 to the 2/3 plus 4/3, which is 3 to the 6/3, which is 3 to the 2nd, which is 9. There are 3 things happening in the exponent. I'm going to apply the negative first, which inverts this. So I end up with 16 over 25, but now it's to the positive 3/2. Then I'm going to apply the denominator, which square roots these. Square root of 16 is 4. Square root of 25 is 5. And now we have just the numerator left. 4 cubed is 64. 5 cubed is 125. As long as the indexes match, we just multiply, and we get 7 times 2 is 14. Here we multiply the outside. 3 times 4 is 12, and then the indexes match, so we multiply. 5 times 3 is 15. Here we do the same thing, but we got to be careful because we're gonna have to simplify. 4 times 2 is 8. 10 times 2 is 20, but 20 we can break down as 4 times 5. When we take out the 4 by square rooting it, we get a 2. This 2 multiplies with the 8 that's already on the outside to give us a 16, and we're left over with the 5. I'm not going to multiply 8 times 6 to get 48 just to turn around and factor it. So instead, I'm going to do this. This is 3 times 2, which is 6, times the square root of, this is 2 times 2 times 2. That's 8. And 6 is 2 times 3. This comes out as a single 2. This comes out as a single 2. And so what we have is 2 times 2, or 4, coming out. The 4 multiplies with the 6 to give us 24 on the outside. And we're left with the square root of the 3. Now, definitely not the only way to do it, but I didn't feel like making this a 48 just to turn around and refactor it down to this. So that's the way I did it. Okay, we have 2 times 3 is 6. Now, I'm, again, not going to multiply this out. Instead, I'm going to factor this, and that's 3 times 3. And I'm going to factor this. This is 3 times 2. And all 3 of these, because this is a cube root, so I'm looking for factors of 3, to come out as a single 3. And this 3 multiplies with the 6 that's already on the outside. And we're left with the cube root of what couldn't come out. All right, I'm going to multiply 5 times 2 and I'll get 10. Then I have the cube root. I'll just put it all together. So I have 2a to the 6 because 2 plus 4 is 6, and b to the 11. And then I'll rewrite this. The 2 remains like it is, the a to the 6 is like it is, but the b to the 11 I'll write as b to the 9 times b to the 2nd. And then I'll take this out and get a squared. I'll take this out and get b to the 9 divided by 3 is 3. So on the outside we have a 10 times that stuff times the cube root of what couldn't come out, the 2 and the b squared. Okay, instead of multiplying 16 times 2, 8 is a perfect cube. So I'm going to rewrite this as 8 times 2 because I know I can take that out. So I'll have 8 times 2 times this 2, and then I'll have x to the 2 plus 4 is 6. When I take this out, I get 2. That's the cube root of 8. When I take this out, I get x squared because 6 divided by 3 is 2. And then we're going to be left with the cube root of what couldn't come out, which is that. But I have to simplify, so that's a 4. Now, I definitely don't want to multiply this times this. The number's going to get too big and I have too much factoring to do. So I'm going to factor this the way I see it. So 36 is 6 times 6. This is 2 times 3. This is 2 times 3. 18 is 9 times 2. And this is 3 times 3. So what I've got is the 4th root of, let's see, 2 to the 1, 2, 3, and 3 to the 1, 2, 3, 4. And then that's it. When I take out this, I get 3 to the 1 because 4 divided by 4 is 1. So my final answer is 3 times the 4th root of what's left behind, 2 to the 3rd power that I have to simplify to 8. Okay, these are like terms, so I'm going to just add the coefficients. This is like, 4x plus 2x is 6x. Same thing, 4 root 2 plus 2 root 2 is 6 root 2. This I'm going to have to simplify. That's 8 is 4 times 2. And when I take the 4 out, I square root it and get 2, which multiplies by that, and we have a 6 root 2. This is 32 is 16 times 2. And when I square root the 16, I get 4. This 4 multiplies with that, and then we get 20. And these are like terms, root 2 and root 2. So we add them up, and we get 26 root 2. I have to simplify that, or break that down. That's 25 times 2. And when we square the 25, we get 5. So this is 5 root 2. 32 is 16 times 2. And when we square root the 16, we get 4. So this is 4 root 2. Those are like terms. 5 minus 4 is 1, but you never write the 1. It's just root 2. And that's implied that this is a 1 root 2. 27 is 9 times 3, because 9 is a perfect square. And we square root this and we get 3. 48 is 16 times 3. We square root the 68 and we get 4. And then these are like terms, so we subtract them, but 3 minus 4 is negative 1. But don't write the negative 1, just write negative root 3. Okay, before you decide whether or not these are like terms, you're going to have to simplify. So I'm going to take out a b squared, it becomes a b. I'll take out a c squared, it becomes a c. This b and c multiplies with this, so we have a 2bc times the square root of the stuff that couldn't come out, the 3a. Okay, now, here, let me write. I'll write it down further down here. 2bc root 3a. Okay, now for this, I'm going to write this as a b times the square root, and I'll write 75 as 25 times 3 ac squared. And I'll take out the 25, it becomes a 5. I'll take out the c squared, it becomes a c. So this 5c multiplies with this b to give us a 5bc times the square root of the stuff that couldn't come out, the 3a. So when we look at this, after the 2, we have this. After the 5, we have this. So these are like terms. They're exactly identical, including the indexes. So we just go 2 plus 5 is 7, and then you write this exactly the way you see it. So BC root 3a. Okay, for this, I'll cube root this, and we'll get an a, and nothing else can come out. So this a multiplies with the 3 on the outside, and we have 3, I'll write it down a little lower. So we have a 3 times the cube root of what couldn't, the 3a, times the cube root of what couldn't come out, which was 2bc squared. And then this 128, I'll break down. This is 2 and 64. This is 2 and 32. This is 2 and 16. This is 2 and 8. This is 2 and 4. And this is 2 and 2. So that's equal to 128 is equal to 2 to the 1, 2, 3, 4, 5, 6, 7. But we're not going to write that as 2 to the 7th. I'm going to write it as 2 to the 6th times 2, because 6 is divisible by 3. And then we have this BC squared, which we can't do anything with that. Okay, I take this out and I get 2 to the 2, because 6 divided by 3 is 2. And this becomes a 4, and it multiplies by the a on the outside, so we have negative 4a times the cube root, let me section this off, of all the stuff that couldn't come out, so 2bc squared. And then when you look at the variable part, after the 3, we have an a times the cube root of that stuff. After the 4, we have an a times the cube root of that stuff. And this part matches identically. So we're just going to go 3 minus 4 is negative 1, but we don't write 1, we just write negative cube root, whatever that, we have an a out in front. A times the cube root of 2bc squared. Pythagorean's theorem says that the square of the two legs, which are touching the right angle, is equal to the square of the hypotenuse. So 4 squared plus 6 squared is equal to x squared. So this is 32, 42, 52. That means that x is equal to the square root of 52. Well, 52 can be written as 13 times 4. And 4 gets square rooted and becomes a 2, so this is 2 root 13. Okay, here the legs are the x and the 6 because they're touching that. So the square of those, the sum of the square of those, is equal to the square of the hypotenuse. I subtract this and I get x squared is equal to 100 minus 36 is 64. So x is the square root of 64, which is 8. Okay, now normally you would have to do the distance formula, but because these are the same, the distance between these 2 points is just the distance between the 2 other values. So 5 minus 2 is 3. If it came, when we subtracted and became negative, you would just make it positive. So in this one, the y's are the same. So the distance between them is 4 minus a negative 2, which is 6. Now, neither of these coordinates are the same, so I do have to use the formula, which is this, x2 minus x1 squared. This is Pythagorean's theorem, y2 minus y1 squared. So x2 is the x value of the second point, x1 is the x value of the first point. So this is 0 minus 7 squared. y2 minus y1 is 5 minus 0. So this is the square root of negative 7 squared is, well, negative 7 squared is a positive 49. 5 squared is a positive 25. So this becomes, let's see, 54, 64, 74. And 74 is 37 times 2, which we can't simplify, so we cannot simplify this. This is just square root 74. So here we're going to do the same thing. The distance is equal to the square root of x2 minus x1. x2 minus x1, negative 4 minus 3 squared, plus y2 minus y1, 2 minus a negative 1. This is the square root of negative 7 squared plus, this becomes 2 plus 1, which is 3 squared, which is the square root of positive 49 plus 9, which is the square root of 58. Now, 58 is 29 times 2, so we can't do anything with that. So this is just the square root of 58. Now, you could just FOIL these, right? First, outer, inner, last. But if you notice, these are conjugate pairs. And the conjugate pairs, when you have a plus b times a minus b, you get a squared minus b squared. So this is our a, that squared is 25, minus this is our b, that squared is 5, and so we get 20. If you forgot that, how to do that, just FOIL it. You could write this out and FOIL it, or if you remember that a plus b squared is equal to a squared plus 2ab plus b squared. That's the shortcut. So this is our a squared is 9, minus the product of these is 6 root 3, but there's 2 of them, so that multiplies 6 times 2 is 12 root 3. And the last thing, b squared, is this squared. This squared is 4, this squared is 3. 4 times 3 is 12. So that's a 12. And when you combine like terms, a positive 9 and a positive 12 give you 21 minus the 12 root 3. Again, you didn't have to know this shortcut. You could have just written this out twice and FOILed it. And after simplifying, you'll get to that. These are conjugate pairs. So you can FOIL it or use this. The a squared is this squared, which is 16 times, this squared is 16, this is 3. So 16 times 3 is 48, minus the b squared, which is 9. 48 minus 9 is, let's see, 39. Again, you could write this out twice and FOIL it, or use this. A squared is this squared, which is 4 times 3, which gives us 12, plus 2ab. It's going to be a minus because this times this is 2 root 15, but times 2 is 4 root 15. Again, AB is this times this, which is 2 times 1 is 2. This times this is root 15, but 2 of them give us 4 root 15. And then finally, we have plus b squared. Negative squared is positive. This squared is 5. So when we combine like terms, this plus this is 17 minus 4 root 15. You're not allowed a radical in the denominator, so we multiply top and bottom by root 2, and we get 4 root 2 over 2, which simplifies, oops, what am I doing? To 2 root 2. Here we're going to multiply by root 3 on the top and bottom, so we get 9 root 3 over 3, which simplifies to 3 root 3. I need to rationalize this, so I'm going to multiply by root 6 on the top and bottom, and I'm going to get 8 root 60 over, this turns into a 6, So 3 times 6 is 18. Now I'm gonna cancel. This becomes a 9 and this becomes a 4. So up in the numerator, I have 4 times the square root. I'm gonna break down 60. That's 4 times 15. And this is all over 9. I'll take out this by square rooting it, and I'll get a 2. This 2 will multiply by the 4 on the outside to give me an 8. And nothing can simplify. I'm going to rationalize the denominator by multiplying top and bottom by root x. So I get root 5x in the numerator and x without a radical in the denominator. There's a lot of ways to do this, but the first thing I'm going to do is rewrite the numerator as this 36 is fine, but I'll write that as y to the 4 times y. And on the bottom, I have the square root of x to the 7th. So I'm going to multiply by the square root of x on the top and bottom. That gives me the square root of x to the 8th on the bottom. The square root of x to the 8th is x to the 4th. And on the top, I take this out and I get a 6. I take this out and I get a y squared. And then I'm left with the stuff in the radical, and I'll put it in alphabetical order, xy. So 6y squared root xy all over x to the 4. On this, I need to get to x to the 4 on the bottom. So I'm going to multiply top and bottom by the 4th root of x squared. On the top, I end up with the 4th root of 2x squared. On the bottom, I end up with the 4th root of x to the 4th, which comes out as just x. So the top is the 4th root of 2x squared. To rationalize this denominator, I'm going to multiply by the conjugate pair. And I have to do that on top and on the bottom. So on the top, I'll distribute this, and I'll get 50 minus 10 root 5. On the bottom, I'm multiplying conjugate pairs, which is the first item squared minus the second item squared. So I have 50 minus 10 root 5 over 20. And I can divide everything by 10. This becomes a 2, that becomes a 5, that becomes a 1. Remember, you never write 1 root 5. So in the numerator, I have 5 minus root 5 all over 2. Okay, on this, I'm going to multiply by the conjugate pair. So I'll distribute this and get 8 root 3 plus 8 root 2 all over, and I'm multiplying by conjugate pair, so I have the a squared minus b squared. This squared is 3, this squared is 2, which becomes a 1 on the bottom, and anything on the, if you have a 1 on the bottom, you simplify and you only have the top. So this is 8 root 3 plus 8 root 2, and that's it.